Let's see if we can create this adder. If I go over here to multimedia logic, and I'm going to need an XOR gate. I'm going to need an AND gate. I'm going to need 2 switches. I'm going to need 2 LEDs. I'm going to need 1, 2, 3, 4 nodes. 1, 2, 3, 4 nodes. And that's about it. I think that's all I need. I'm going to move this over like this so you can see it. Bring this down. Move these guys over a bit. Get some fighting room. There's my LED. And there's my other LED. I don't need the palette anymore. Let's get rid of him. Make this bigger. Like so. Okay, okay. Now, oh, I needed to wire this up. So from here to the node to the XOR gate, and from here to the node to the XOR gate, and then from this node down to here, down to the AND gate, and this node down to here, then from this node to the AND gate. Make these guys up, make these guys up, like so. Go back to the selector. Let's see if I can straighten it out, make it look a little bit nicer. There we go. That looks nice. And move this down. That looks nice too. Let's move this up. Good. Maybe a little bit more. Good. There we go. And this guy. Whoa. There we go. So from this light, I've got a connection to the XOR gate and to node 1 of the XOR gate and node 1 of the AND gate. This light goes to node 2 of the XOR gate and node 2 of the AND gate, and they both go to LEDs. Alright, now let's see if they follow the rules we stipulated down here. Yes? We got an XOR gate here which represents our sum. And we've got a carry which is represented by our AND gate. So let's see if it follows the rules we set up over here. When x is 0 and y is 0, 0 plus 0 is, let me change this to a thicker and darker color so you can see it. There we go. When you get a 0 and a 0 here, they add up to a 0 and the carry is 0. So 0 and 0, let's go into simulation mode. When I got a 0 and a 0, both of these guys should be dark because I got the sum, which is represented by the XOR gate, this guy here, and the carry is represented by the AND gate here. So when it's a 0 and a 0, I should get a 0 here and a 0 here. Let's see why. 0 and 0 to the XOR gives me a 0 because it has to be exclusively a 1 on this line to turn this on. With the AND gate, I'm getting a 0 and a 0, and 0, 0 is 0, so it stands to reason. Both are off. So that checks out fine. Now, 0 and a 1. So this guy is going to be 0, this guy is going to be 1. When that happens, 0 and a 1 is a 1 on the sum. And the sum is the XOR gate, this guy here. This guy here where the arrow is pointing to, this guy here. This is going to be the sum. This will light up, this will not. I'll have 0 and a 1 would give me a 1 and a carry of nothing, and the carry is on the AND gate. So this will be black, this will be on. Let's see it. 0 and a 1. Here it goes. Oh, the XOR goes on. The carry is 0. The AND gate is off. What's the next value? 1 and a 0. And that should give me, well, 1 and 0 is 1 on the sum, and 0 on the carry. So this will remain like so. Yes? So let's turn this guy on. Oh, there we go. I've got a 1 on the sum. There's no carry because 1 and 0 give me 1. No carry. No carry to the AND gate. Okie dokie. Let's go to the next one. The last one. A 1 and a 1. A 1 and a 1 will give me a what? A 0 and a carry of 1, giving me a 2. Ah, okay, so what does that mean? It means this will be the sum is represented by the XOR gate, and the carry is represented by the AND gate. It will go on, this will go off. AND gate will go on, XOR will go off. Here we go. Well, there we go, it worked. 1 and a 1. 1 and a 1 shuts this guy off. 1 and a 1 turns the AND on. Son of a gun, it worked. That was the equivalent of 1 plus 1 is a 0 and a carry of 1 into column 2. And column 2 is represented by the AND gate. Huh, what do you know? Well, that's it. Thanks for listening, and bye-bye now.